I took a copy of the practice test. This is 2.08 practice, and I just printed it. And so I'm going to do it on paper. When you do the practice test, if you've already done it, you may not have had the exact same problems because every time you do a quiz or test, it has a bunch of questions it can choose from. So it just picks a question out of that. So these questions may not be exactly what you've seen on the practice test, but it should be a very, very similar problem. It should work the same way, just with different numbers perhaps. But I'm going to work with this first and solve -2 times 2x plus 5 minus 3 equals -3 times x minus 1. Now, anytime it says solve, that generally means find what the variable equals. So what does x equal in this equation? So first we need to simplify it. So parentheses are going to come first. So we need to take the -2 and distribute it inside, and take the -3 and distribute it inside. So I'm going to write it over here. -2 times 2x, -4x, -2 times 5 is -10. And then we have a -3 equals, and then distributing the -3, -3x, -3 times -1 is a +3. Now we just need to simplify. These combine because they're both just numbers. So we got -4x minus 13 equals -3x plus 3. Okay, so now I need everything that has an x on the side of the equal sign and everything that doesn't have an x on the other side. So I'm going to go ahead and move this to the other side by adding 4x. Right now it's a -4x. So if I add 4x, that goes away. I have to do it on both sides for it to be equal. And I'm also going to move the 3 to the other side. I'm moving the x's this way, so I'm moving the numbers the other way. So this is a +3, so I'll subtract 3, and we'll do them at the same time. Hey, welcome, Emily. I'm just getting started on the first problem here. So this cancels out. We have -16 on this side. Cancels out. So we have -3x plus 4x. That's a positive x. So x equals -16 on that first problem. Welcome, Isabella. I'm doing the test review. I just took a practice test, printed out a version of the practice test, and we're working through it on paper. So that's the first one, -16, just by solving for x. Okay, the second problem, very similar. Solve this. So we have to distribute first. We got to get rid of the parentheses. So 4 times x is 4x. 4 times 1 is 4. And the other side is already simplified. So we got 4x plus 4 equals 4x plus 4. Well, that already looks very interesting. We can go ahead and solve it. If we take -4 from each side, we got 4x equals 4x. I'm looking at our choices. No solution, 0, all real numbers are 1. If we divide both sides by 4, we got x equals x. So it doesn't matter what x is. It's all real numbers would be true. If x is 7, 7 equals 7. If x is 0.2, 0.2 equals 0.2. X is -10, -10 equals -10. We could have subtracted 4x from both sides, and we have 0 equals 0 if we subtracted 4x. And still, that's a true statement. So it doesn't matter what x is. X can be any number, and 0 will always equal 0. But I just simplified it to say that when we have the same thing on both sides, that means it doesn't matter what x is. If x is 1, it'd be 8 equals 8. If x is 2, it'd be 4 times 2 is 8, plus 4 is 12. 12 equals 12. Always, any x is true. So all real numbers. All right, let's look at the third one. Solve for 2/3 times x minus 2 equals 4x. All right, well, I don't really care working for fractions. We could work with fractions, but I'd rather not. So to get rid of a fraction, you multiply everything by whatever the denominator is. So we're going to multiply this side by 3, and we're going to multiply this side by 3, because that's the denominator. Well, since this is going to be multiplied into that, this cancels out here, and this becomes just 2 times x minus 2. I could have distributed that first, and I have 2/3 x minus 4/3 and multiply that by 3. But it's easiest to leave it outside the parentheses. And of course, 3x times 4 is 12x. So 2x minus 2, I need to distribute. 2x minus 4 equals 12x. All right. Put all the x's on one side. So that cancels out. I've got -4 equals 10x. I'm still trying to get x by itself. I'm trying to solve for x. So we'll divide everything by 10. So x equals -4 tenths, which this simplifies. Notice we don't have tenths over here, but we can divide a 2 into the top and the bottom. So that's the same thing as -2/5, which is our first choice right there. That is -2/5. It's hard to see it, but there's a little negative printed there. These two are negative and these two are positive. It doesn't show up real well on the camera. So that is -2/5, and that is our answer for number 3. All right, let's work through the next one to see. And hopefully some of these you're like, oh yeah, I know how that one works. But if we run across one that you don't, this may help with that. Okay, this is a little trickier. Kyra observed that 85% of the students at a library liked reading mystery stories. If 30 students at the library did not, and that's our key word in there, did not like reading mystery stories, the number of students at the library who liked to read mystery stories was, and we have to put just a number in there. No other symbols. Don't put equals. Just put a number in that blank, or the computer won't know how to grade it. So all we know is we don't know how many people there were. We only know that there's 30 people that did not like it. And we know that 85% of people did. So 100% minus 85 means 15% of people, right, did not like reading. So what do we know about that? We know there's 30. So 50, the total number of people, we're just going to call X. Total number of people. We don't know how many people there were, but that would be the total number of people at the library. And we know that 15% of them, now as a decimal, 15% is 0.15. You just put a decimal in front of this number, and that makes it equivalent to the percentage. So 0.15. 0.15 times the total number of people, so it'd be 15% of the total number of people, we know is 30. We know how many 15% equals. 15% of the people is 30. So from this, we can find out the total number of people. So if we divide both sides by 0.15, all right, I'll just pull out a calculator. There's an on-screen calculator we can use if we were doing this on the computer, but I'm just doing this by hand, so I'll just use a handheld calculator. 30 divided by 0.15 is 200. So X equals 200. All right, that's not our answer, because they just want to know the number of students who did like mystery stories. Well, there's 200 people at the library. We know 30 do not like it. So 170 people like reading mystery stories. So we just have to go with what they gave us. They just gave us 30 people, and we know that's 15% of the total people there. So we had to use that to figure out how many people there were so we could get how many like mystery stories. So just got to play with what they give you. Let's see. Let's look at the next one. The table below shows the ticket rates for whale watching trips offered by Ocean Tours. Okay, so under 3 and free. We gotta look at our key information. Under 3 years old is free. Okay, and 3 to 12 years old is 36. And over 12, it's $48. So there's kind of our key information to start with. It says on a certain day, a company took 92 people on the whale watching trips. Okay, so 92, that's everybody. There are 40 children aged 12 and under, of which some of those were under 3. So these two groups together, we know there are 40 children. Some are in this group, some are in this group. We don't know yet how many. We just know there's 40. So I'm trying to keep that organized. And we know there's 92 people total. So if there's 40 of them, they're children, that must mean there's 52 adults, right? Because 92 minus 40 children equals 52 adults there, or at least over 12, not necessarily adults, but at least over 12 years old. If X represents the number of children under 3 years, okay, so they were saying this is X. All right, X is going to be the children 3 years. Which equation can be used to find the value of X? Where C is the total money. All right, C is total amount of money collected. All right, so let's see what we know. We know that there's 40 altogether. We know this is X. Well, if this is X, then we can name this 40 minus X, right? Because we know however many children here, we just subtract this many. We know there's 40 total. So if we subtract the number that's under 3, that'll tell us how many are in the 3 to 12. Okay, so the 3 to 3 years old is free. The 3 to 12, which is 40 minus X, is $36. All right, and then 52 people get charged $48. So let's look at the equations they give us and see which one makes sense. They all equal the total money collected, so we don't have to worry about trying to figure out which equation on that side. They're all equaling the total money. So this is 92 minus X. What would be 92 minus X? The total number of people minus the children under 3 times $36. Well, that's not going to be accurate. Let's just put a number there and pretend there's 10 kids under 3. Well, that means with this equation, 82 people get charged $36. We know that's not right because there's not 82 children between 3 and 12. So there's something wrong right there. And I'm going to say, okay, it can't be that one. How about 40 plus X equals 36? 40 is the total number of children, and then they're adding again the number under 3 and charging $36. Well, that doesn't make sense either because we don't have a 40 plus X. 92 plus X, total number of people plus the number of under 3 years old. Well, that's going to be more people than was there because this is the total of everyone and charging $36. That makes sense. So hopefully it's this last one, but I'm going to look at it to make sure I haven't missed something. 40 minus X is $36. Well, we said 40 minus X would be the number of 3 to 12-year-olds because there's 40 total and X is this number. So 40 minus X should get charged $36 each. Okay, that works. That works. 40 minus X times $36 plus 92 minus 40 get charged $48. Well, 92 minus 40, 92 total, 40 of them get these rates. So that means 52 people get charged $48. This would be 52 combined times $48. So this one works. That has to be the equation. And we don't have to calculate how much money. They didn't ask us to calculate. We don't have to figure out how many is under 3 or anything. They just want to know which equation would be used. So by process of elimination, looking at what information they gave us, it helped when I wrote this. X is under 3. 40 minus X must be 3 to 12. We're able to figure out which equation would solve that for them. Okay. Here's a good one down here that a lot of people figured this out real quick, but then didn't think about it and gave the wrong answer. So the sum, that means we're adding, right? Of 2, you got to get the key words in here. The sum is the key word. It means we're adding 2 consecutive even integers is 234. So if we add these together, so let's say we had an integer that's an even integer. We don't know what it is yet. Could be 100. The next even integer would be 2 bigger, right? Because the next one is odd if it's even. So we need to go n plus the n plus 2 would be the next even number. And when we add those together, they have to equal 234. So an even integer plus the next even integer, 2 consecutive, have to equal 234. So let's simplify this. N plus, this is just a 1 out here, so we don't really need the parentheses. N plus n is 2n, and then we have a 2 equals 234. All right, so subtract 2 to get x by, or n in this case, n by itself equals 232. Okay, so then we divide both sides by 2. All right, just to make sure we've, oh, there's a negative on it. 232 divided by 2 is 116. It's 116. And we want to choose that, but that's not what it's asking. What is the, here's the key word that means everything right here. Larger integer. We know we were looking at n and the next one that's bigger. Since and this is 116. The next number must be 118. And which one's larger? 118 is larger. And we can always check ourselves. We said those are the two answers, 116 plus 118. 8 plus 6 is 4, carry 1, 111 is 3, 234, that's what we were supposed to equal. So those are the two even integers that are consecutive, one after the other, that add up there, and it wants to know what's the larger one. So solving for n is not the end of that problem. You got to look at what they're asking for. 118. So, all right, let's look at number 7 here. Okay, in a certain county, the number of charter schools is 6 less. Okay, let's get the information. 6 less, that tells us subtract, then twice the number. Twice the number of, that means we're multiplying by 2 of alternative schools. So charter schools is equal to 2 times the number of alternative schools minus 6. All right, so let's give a variable for alternative schools, or say that's an A. And so the number of charter schools is equal to, charter equals twice the number of alternative, 2 times A minus 6. It's 6 less than that. It's 6 less than twice the number of them. So the charter schools is 6 less than 2 times the number of alternative schools. We know there are 52 charter schools, so how many alternative schools? So if we know there's 52, we'll make that 52 equals 2A minus 6. All right, we just substitute that in. So let's get A by itself. Add 6, 58 equals 2A. Divide both sides by 2. 58 divided by 2 is 29 equals A. That's how many alternative schools. It's asking alternative schools. A is 29. 29 is our answer. Now, if anyone has questions as we're going through this, please turn off your mute and speak into your microphone so I can answer any questions. Okay, perimeter. The perimeter of a rectangle can be found using the equation. The perimeter is twice the length plus twice the width. Well, we know a rectangle, when we talk about perimeter, that's the total distance around it. The length and the length and the width and the width. Say 2 times the length, because there's 2 of them, 2 times the width. And if we add all those together, that's going to give us our total perimeter. So P is the perimeter, L is the length, W is the width. Can the perimeter of a rectangle be 60 units when its width is 11, and the length is 24? Okay, well, looking at it, we could add it up, but let's use their formula. So they said P equals 2, and they said the length was 24, plus 2, and they said the width was 11. So P would equal 2 times 24 is 48. 2 times 11 is 22. So the perimeter, 48 plus 22 is 70. So these two can't be right. They're saying, yes, it can be 60. So it has to be one of these. No, if the length is 24 and the width is 11, the perimeter would be P equals 48 plus 22 equals 70, not 60. That's what we had, P equals. So this one looks right. Let's check the other one. If 24 and 11, the perimeter would be P equals 24 plus 22, 66. No, that's not right. So the first one, yeah, those are the wrong. It's not 40, not 24. It's 2 times that's 48. And 24 and 22 don't equal 66 anyway. They equal 46. So there's problems right there in the math. So we found reasons to eliminate these other answers. This is the correct answer for our perimeter of a rectangle. All right. Let's look at the next one. The table below shows 2 equations. Oh, now we're in absolute value. Absolute value of 4x minus 3 minus 5 equals 4. And remember, absolute value is like if we had a number line, and we have 0, absolute value is the distance from 0. It doesn't matter what direction. If we have 3 over here, the distance from 0 to 3 is 3. Over here, if we have negative 3, the distance is still 3. It just went this direction. Remember, a distance got to be a negative. You can't pull out a ruler and measure something and say, oh, this is -7 inches long. Distances are always positive. It doesn't matter which direction, it's positive. So -3 and 3, if we take the absolute value of them, they both equal 3. Absolute value can never be a negative number because it's a distance from 0. Absolute value is always when you put something inside the absolute value, it's always going to be positive when it comes out. So this is going to be some positive number, whatever it is. And this is going to be some positive number, whatever it is, 0 or higher. So without solving this, we can look at it and get a few ideas. We can also solve it, but let's look at it first. If we take a positive number and subtract 5 from it, is it possible to end up with 4? Well, sure, if that positive number is 9, if it's a 9, if this in there is 9, 9 minus 5 is 4. So it is possible to have that answer. So for this to be a 9, 4x minus 3 could be 9, which means we add 3. 4x would equal 12. Divide by 4. So if x equals 3, then this is a true statement. But there's another possibility. This could also, inside there, 4x minus 3 could equals -9. Because -9, the absolute value of -9 is also a positive 9, because that's 9 away from 0 this way, where the other one was 9 away that way. So whatever's inside there just has to equal a positive 9 when it comes out, which means it could be a positive 9 or it could be a -9, that expression inside there. So if it's -9 and we add 3, we got 4x equals -6. We divide that by 4, we get x equals -6/4, which is the same as -1 1/2 if we change that, or 1.5, negative 1.5. So let's look at what we have down here. Oh, we haven't looked at the second one. Is there any positive number we can take and add 8 to it and end up with 3? I can't think of any, because the smallest number we can have is 0. 0 is not really considered positive or negative, but this could be a 0 inside there. 0 plus 8 is going to be bigger than 3. The only number that we can add 8 to and end up with 3 is -5. -5 plus 8 equals 3. But that's it. So is there any way that inside the absolute values that can come out of the absolute values and be a -5? No, because absolute values are always a positive number. So there's no solution to that. There's no way that we can make it a -5. So equation 1 and equation 2 have no solutions. Well, that's not true, because we found solutions for equation 1. So that can't be right. Equation 1 has no solution, but equation 2, no, equation 1 did have solutions and second one didn't. So this one says the solutions to equation 1 are 3 and -1.5, which is what we got, 3 and -1.5. And equation 2 has no solution. This one says 3, 1.5, and equation 2 has solutions of -4 and 1. We know there's no solutions to equation 2. So our answer is right there. 3 and -1.5. Equation 2 has no solutions, because we can't get a positive number and add 8 and get to 3. So we can look at little things like that without ever having to do a bunch of solutions in there. Okay, here it says, here are the steps to solve an equation. Number 10. It's the work to do, and we're supposed to say which is the following correct next step. All right, so these are correct. We just know which one's next. So if it starts with x minus 5 plus 2 equals 5, the first thing they did was get rid of this positive 2 by subtracting 2 from both sides. Right? When they subtract 2 on this side, it goes away, because 2 minus 2 is 0. So we just have this. On the other side, we have right there where they took the -2 from that side. So then they just simplified. X minus 5 absolute value equals 3. which is what I must do. So where do we go from there? All right. Do we do x plus 5 equals negative 3? Because remember, there's two ways for this to end up being 3. Either x minus 5 inside has to equal 3, or x minus 5 has to equal negative 3, or either one of those. Or, so it's either going to equal 3 or negative 3. Well, it's not going to be x plus 5. That's a problem right there. That tells us right there that that's wrong. So we can scratch that one out. Negative x minus 5. Negative x minus 5 is not the same as x minus 5. That's a problem right there. We can scratch that one out. X minus 5 equals negative 3. That is one of our next solutions. So we got to figure. X plus 5 equals 3. Well, again, we don't have an x plus 5. That plus is a problem. So without even having to continue solve, we know that's the next step right there. That's the next step. Because the others change it. X plus 5, negative x. We don't have plus 5 or negative x. So that is the only solution. And we don't have to go any farther than that because it's just asking what's the next step. All right. Here's another one. And here's the equation. Absolute value of 2x minus 4 minus 3 equals 3. Okay, well, there should be a solution to that because we can take a positive number, subtract 3 from it, and get 3, right? If it's in when it comes out of there. So it could be a 6 or a negative 6 inside there, and it'll be 6 when it comes out. So this shows the solution. Let's look at what it's asking while we go through this. What's the first incorrect step? That's the key word. What's the first step that's wrong? All right, well, how would we solve this? Well, we have to get the absolute value by itself. So this negative 3, we're going to have to move it to the other side, right? So we'll have the absolute value of 2x minus 4 equals 3 plus 3 is 6. Let's see what they did. They moved the negative 3 to the other side, right there. Negative 3 moved to the other side. But they did it wrong. You have to add 3 to move that negative 3. We have to get rid of it. Got to add 3 both sides. Should be 3 plus 3. They did negative 3 plus 3, so they come up with 0 instead of 6 because they just took the negative 3 and they just moved it over. They didn't add 3. They just moved it over. So they made a mistake right there at the very beginning, step 1. We don't have to look any farther because the rest of that's all going to be wrong because they did it wrong right there at the very beginning. Step 1 is incorrect. All right, let's move down here. Again, what's our key word? Not. Which of the following is not a way to represent the solution of the inequality 2 parentheses x minus 2 is less than or equal to 2? Okay, well, it looks like there's going to be a 3 in the answer. But we need to figure out what the answer is so we know which is correct here. So let's get rid of the parentheses. 2x minus 4, because we have to do that to both of them, right? 2 times x, 2 times negative 2, less than or equal to 2. Trying to get x by itself, so add 4. 2x is less than or equal to 2 plus 4. So divide by 2 to get x by itself. X is less than or equal to 3. Remember, the bigger side has the bigger part of the inequality. So this must be bigger than this because that's pointing at the little guy. The big side is open to the big number. The little point is the little guy. X is less than negative 3. So let's look at our choices. One of these is not the way to represent that. A number line with a closed circle. Remember, if we had a number line, because with inequalities, we can represent that on a number line. If this is 0, 1, 2, 3, if we're going to represent this on a number line, if it's less than 3, you put a hollow circle. If it's got the equals, we got to put a closed circle, right? Because of that equals underneath it. Equals means we fill it in. And since x is everything less than 3, everything less than 3, we would be going that way, right? So on the number line, I'll put it in red where it stands out a little better. Everything less than that 3. So which of these do not represent it? X is less than or equal to, well, that's exactly what we had. So that's right. We want what's not the way to represent it. 3 is bigger than or equal to x. 3 is greater than x. Well, yeah, 3 is greater than. This is just taking everything and turning it around. Right? X is smaller. X is still smaller here also because it's still pointing to the x that's smaller. You just took it and turned around. A number line with a closed circle, a number line with a closed circle on 3. So these are the same up to here, but this says shading to the left or shading to the right. Shading to the left is correct. To the left. So this one is not the way to do it. That would be our choice. It's easy to get lost on these ones that say not, because we want to look at that and we say, yes, it goes left, and we want to choose that. But pay attention. Don't let it get you on the easy stuff. It's just saying not. So all of these 3 are the same, and they're all correct. This one's different. Not a way to represent that. All right, number 13. We're doing well here. All right, choose the missing step in the given solution to the inequality. Negative 6x minus 10 is greater than 14 plus 2x. Okay, so first thing they did is just write the equation down. And then from there, they got to negative x is greater than 24. So somewhere in there's a step. What are these all? Okay, these all still have the minus 10 and the 14. So they didn't do anything with this, right? So they must have only done something with, oh, I'm sorry, I did the wrong one. Did this one and this one. The 14's right here. I just did the second one of both of them. So they did something with these two to go from there to this. So what did they do? It looks like the 14's by itself, so they must have subtracted 2x. Subtract 2x, so you got negative 8x minus 10 is larger than 14. Which one of those is that equal? We got 2 of them that have negative 8x minus 10. The secret, the key, is look what's different. We have to make sure we're choosing the correct one. Since all we did is subtract, it's still a greater than. So this is our answer. Remember, if we multiply both sides or divide both sides, multiply or divide by a negative, that's when we have to turn the sign around. Then it would turn it around like this to that. If we multiply or divide by a negative. That's the only time that we change that. So instead of this, it goes to that if we multiply or divide by a negative. But we didn't do that. We just subtracted. Excuse me. Subtracting does not cause us to have to change the sign. All right. So which of the following is not a way? Again, here's that not. We're going to pay attention to that. Not a way to represent the solution of the inequality. 8x minus parentheses 5x plus 4 is greater than, it's kind of hard to see that. I'll make that bigger. Greater than or equal to, and I'm going to move the negative 31 back over here. Put it on the next line. So greater than or equal to negative 31. So they've got it down to a negative 9 somewhere. Let's figure out the answer so we know which one of these is correct. So 8x minus 5x. I'm going to go ahead and just do that math. 8x minus 5x is 3x. Now, to distribute this, I probably should do that step. Let me do that step first because we are distributing. And what are we distributing? There's a minus out front. That means there's really a minus 1. We're distributing a minus 1 in there, so this will be 8x minus 1 times 5x is minus 5x. And minus 1 times 4 becomes a negative 4 is greater than or equal to negative 31. So don't get messed up in that. So to move that over, we got to make this plus 4 now. because that's a minus 4. And over here, this combines. So 8x minus 5x is 3x. This goes away. Negative 31 plus 4 greater than or equal to negative 27. We're dividing by 3. Again, we're dividing, but we're not dividing by a negative. Not a negative. So we don't have to change the sign. So x is greater than or equal to negative 9. X is bigger. X is greater than or equal to negative 9. Negative 9 is smaller than or equal to x. Well, that's true because x is bigger. We said x is bigger, so 9 must be smaller. A number line with a closed circle, they both have a closed circle because it has the equal underneath there. But is the shading going left or the shading going right? If x is bigger than 9, we've got a solid circle at 9, and x is bigger, it's everything bigger is x. X is over here, everything. So not to the left. Not shading to the left. Again, don't let this mess you up. This is a lot of people are going to choose to the right because we get that, or you may choose one of these, but look at what it's asking. Don't let that fool you. Okay. Abby wants to use her savings of $1,325 to learn yoga. Abby really wants to learn yoga. She's going to put a big investment. The total charges to learn yoga include a fixed registration fee of $35. Fixed. That means it's not changing. It's just one time, it's fixed. And this is a monthly, there's a key word, monthly fee of $50. So what's the maximum number of months for which Abby can learn yoga with her savings? All right, so let's do an equation to figure out how far her $1,325 gets her. Her $1,325 will be equal to $35 is a fixed fee. There's just one time. Plus she has to pay per month $50 M, I will say. So M is month. All right, M is month. And so $50 per month. So let's solve this to see how many months she can go with her $1,300. So minus 35 to move that over since there's no variable with it. So we can do that in our heads, but I'm going to go ahead and put on there just so you can see it's right. Oops. $1,325 minus $35, $1,290 equals 50 months, $50 a month. So if we divide both sides by 50, we'll see how many months you can get. So let's divide by 50. 25.8 equals the months. Now, here's our choices, 24, 25, 26, 27. Generally, in math, you look at a number and you want to round that up. But she can't afford 26 months. You can't buy part of a month. It doesn't matter if that's 0.95. It's not 26. 25 months is how much you can go, and she'll have some money left over, but not quite enough money to buy another month. Years, and should have yoga down pretty well. And an extra month, 25. But don't round that up because we're talking about purchasing something, and she doesn't have enough money to buy a complete month. And so this doesn't give any option on partial months. So that's where you have to, or you'll end up choosing the wrong answer just out of habit of rounding. So you have to look at the context of the problem. And the context of the problem, we can't do any decimal. All right, let's see this. Ooh, this has a lot of writing. All right, we're supposed to choose the correct description of the graph of the compound inequality. All right, so here's our description. So let's look at it. What's the key parts on here? Well, I see right away there's an or right there in the middle. So that means X can make two different things true. It doesn't have to be either both. Just either one of them will make it true. So let's see what X can be. If this is X minus 3, that means we would add 3. I'm going to write that over here. So this would be just X left on there. X Still less than, because we didn't multiply or divide by a negative. Less than negative 9 plus 3 is negative 6. Okay, that's one solution. X could be anything less than negative 6. It could be negative 6.5, negative 8, negative 100. Or, there's the big key to it, or X could be, let's see, subtract 5. Could be X is greater than or equal and 10 minus 5. So X could be bigger than 5, or it could be less than negative 6. So this is saying, what's it going to look like on a number line? So if we had a number line, all right, now we've got 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so there's 6. There's 5. There's 0. Now I'm just marking those numbers on there. So X greater than or equal to 5. So we got to fill that one in because of that equal to. And X is everything bigger than that. So I'm going to use this so it shows up better. Everything bigger than that. All right. Or it also could be X is less than negative 6. There's no equals. This is just less than. So this is going to be a hollow circle at negative 6. And X is smaller than that. So it's going to go this way. So if X is in either one of these areas, that's true because it says or. So what is the description for this? A number line with an open circle on negative 6. Yes. Shading to the left. Yes. And the closed circle on 5, yes, shading to the right. It looks like this is our answer right here. I'm just going to verify I'm not reading something wrong. A number line on a closed circle on negative 6, shading to the left, yes. And an open, well, we know that's not an open circle. So anything says open circle on 5, closed circle on 5, open circle on 5, we know those two are wrong automatically. This one has the open circle on negative 6, closed circle 5, and shading in between. We did not shade in between, so that's why those are wrong. So this is the correct answer. I just double checked, but I found problems with the other 3, so that would be the solution. All right. So let's look at number 17. Choose the correct description of the graph of the compound inequality. All right, so let's figure out. First thing I see on this is an and. Both of those have to be true for X, both of them. So let's see, I'm going to draw my number line up here. We'll use that in a few minutes. But let's figure out what the solution is first. So we're going to subtract 5 from both sides. So over here, 2x, the 5 goes away, greater than 9 minus 5 is 4. I need to divide both sides by 2 because I have an x. So this is x is greater than 2. All right, x is greater than 2. And 5x, I've got to divide both sides by 5. 5x divided by 5 is x. This is less than or equal to 30 divided by 5 is 6. So x has to be larger than 2 and smaller than or equal to 6. So 1, 2, 3, 4, 5, 6. If I have a 6 and a 2, then we have negative numbers over there. We would have at 2 a hollow circle, an open circle, because there's no equal. An open circle. Again, I'm going to change and do this in red. And at 6, we would have a closed circle. It has to be x has to be bigger than 2, so going that way, and it has to be smaller than 6. So in between there, bigger than 2 but smaller than 6. So it has to stay in that range. So let's see what our choices for are here. Open circle on 2, yes. Open circle on 2, closed circle on 2. I can eliminate. Right away, I've eliminated 2 answers just because it's a long circle. This has closed circle on 6 on both answers. All right, so this is shading to the left of the 2 and shading to the right of the 6. We did not do that. This says shading in between. That answer, shading in between. All right, let's move down here. Okay, this gets a little different. Now we're putting it in a story. A company did a quality check on all the packs of roasted. Each pack of roasted almonds is targeted to weigh 21.25 ounces. That's how much they want each one to weigh. And it's got to be within 0.24 ounces of the target to be accepted. So it can be a little heavier than that. It can be a little than that. All right. What is the range of, here's one of those key terms that mess us up when we're trying to do this. Rejected. What is the range of rejected masses? They're calling that X for the manufactured roasted almonds. So our answer is not which ones are good, because, on a number line, if we had a number line and we said this is 21.25, and if we went bigger by 0.24, then we'd have, and I'm just going to put them out here, 21.25 plus 21.49, and smaller than that, but still in the range, is 21.01. So everything between those two, I'm going to put it in this color, must weigh within that. So that would be okay. 2101 would be closed circle, because it could be that amount. It has to be anywhere in there. That's how much any one of their packets of roasted almonds can weigh. Anything between 2101, right? So rejected would be anything that's not there. Everything, if it's too heavy or too light, that gets rejected. So which one of these represent that? Okay, first off, less than 2101 are, okay, that's got potential. Less than 2125 or greater than 2149. No, it can be less than 2125. It can be all the way down here. So that's out. Okay, this says less than 2101 or greater than 2149. So that's true. And this one says less than 2125. Oh, again, that's at their target, but it can be less than that. So these two orange ones are both correct on the graph. Let's look at this part of it, because it says because X minus, and X is the mass, minus 0.24, which is what's allowed, plus adding this has to be greater than 0. Well, that doesn't make sense to add the weight when you already had the mass and subtracted the variance and add the weight back. This one says if we took the weight of the roasted almonds and subtract 0.24, if we subtract that and take the absolute value and then add 2125. Oh, sorry, I'm looking at the wrong one. This was one of our discarded ones. If we take that and subtract what it should weigh, whatever it weighs minus what it should weigh, the absolute value of that should be larger than 0.24. That would mean it's outside. That means it's rejected. So this is the one I like right here, because it says if I take what this package weighs and I subtract what it's supposed to weigh, if it's larger than 0.24, that means either too light or too heavy. It's outside what's allowable. This one, we're taking the weight of it, subtracting with the variance, and then we're adding the weight of what it's supposed to be. So you're going to have really big numbers sometimes. If it weighed 22, 22 is too big. If we take 22 and we subtract 0.24 and then add 21, we're talking about a 43. And you see, doesn't make any sense. So this one right here. All right, let's move on. We don't have many left. We're down to number 19. Okay, Zoya has to earn at least $300 to meet her fundraising goal. Okay, that's what she wants. She wants $300. At least, that's a key word. At least $300. She has only 100 bracelets that she plans to sell. Only 100. That's it. She doesn't have any more. That's all she can sell. It's only 100. And she plans to sell for $5 each. Okay. $5 each. So which inequality shows the number of bracelets X, all right, that she can sell to meet her goal? Okay. Well, she wants to make at least 300. So if she's selling each of them for $5, 5 times the number of bracelets should be at least $300, $5 for each bracelet. So at least means it can be 300 or it can be bigger. It didn't say over 300. She must earn over 300. It says she must at least 300. So that means it can be equal to 300. So we're trying to figure out the number of bracelets she sells. How many number of bracelets can she sell to get her $300 or more? All right. So divide both sides by 5. X must be larger than or equal to 60. 300 divided by 5 is 60. So that's how many bracelets she has to sell at least to get her $300. She can sell more. Let's look what we have. This says she has to sell at least 20. No. That says she has to sell at least 100. She does not have to sell at least 100. Both of these say she has to sell at least 60. So why is there an upper range? 300 or 100? Well, that goes back to this statement right here. She only has 100 bracelets. So she can sell 60 of them or she can sell all of them, and that will get her at least $300. She doesn't have 300 bracelets. Since X is the number of bracelets, it's not the dollars. X is the number of bracelets. We can't sell more than the number of bracelets. So that's out. Okay. Solve for X. And we have negative 3X plus 3B is greater than 5. So we solve for X. That just means get X by itself. Anything that's not an X has to go away. So the first thing we see is a plus 3B. So we're going to subtract that because there's no X. 3, I want it to look like a 6. B minus 3B. So over here we have negative 3X is greater than, and we got a negative 3B and a 5. You can either write that 5 minus 3B, or usually we like to put variable, the negative 3B, and that's a positive 5. So we'll be adding 5 to it. A negative plus the positive or the positive minus that ends up the same number. If you're not sure about that, let's say B equals 2. So 5 minus 3 times 2 is 6. That's negative 1. If this is a 2, negative 3 times 2 is negative 6 plus 5. Negative 6 plus 5 also is negative 1. See, it works either way. Those are equal. These are equal statements. But we'll go ahead and write the variable first, just because that's generally what we do in math is write the variable first. Negative 3B plus 5. So we're going to divide by negative 3 because, again, we're just trying to get X by itself. Okay, negative 3. And, oh, ding, 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 ding. We have just triggered something. We have divided by a negative, and that affects our sign. Remember, multiply or divide means we have to do something with that. So negative 3 divided by negative 3, this is X. Now that changes because we divided by a negative. It changes. And this is negative 3B plus 5 over negative 3. Hey, look at there. X is less than negative 3B plus 5 over negative 3. That one matches our statement. This 5 minus 3B is the same thing. 5 minus 3B divided by negative 3. That's the same thing. But that's where we've got to pay attention to that right there. That's what makes that wrong, is that said the X is greater than. We had to change that. Otherwise, this could be the answer, except for it has the wrong inequality. So little details that try to throw us off in doing this. Let's see. This is our last page. Here's the last problem we're doing right here. 2 problems. Solve for H. Oh, this isn't bad. Solve for H. And our equation is A equals L times W times H. And if we want to solve that for H, that means get H by itself. Right now, H is being multiplied by L and W. So if we divide it by L and W, these cancel out. So this is H equals A divided by L and W. That's right there. H equals A divided by L and W. And that's pretty quick. Let's look at this last one. Same type of thing. We're just a little bit trickier. The equation shows the relationship between the temperature in degrees Celsius and degrees Fahrenheit. So Fahrenheit is 9/5 times the Celsius temperature plus 32. So if we want to solve this for C, we've got to move everything away to where the C is by itself. So F equals 9/5 C plus 32. First thing, C by itself, let's get rid of the 32. So now you got F minus 32 equals 9/5 C, because those canceled out. So to get C by itself, we got to divide by 9/5. Now, those of you who remember working with your fractions, if you divide by 9/5, you have to reverse that to 5/9 and multiply. That's how fractions work. Anytime you divide by a fraction, that's the same as multiplying by the reciprocal. 9/5 becomes 5/9. So dividing this by 9/5 makes it multiplied by 5/9 times F minus 32, and that would equal C. So our choice is 5F minus 32/9. No, 5/9 times F. No, it also has to multiply by the 32. 9/5, it didn't get reciprocals. So 5/9 equals F minus 32. And that is to find the Celsius temperature. If you know the Fahrenheit, subtract 32 degrees from it, multiply it by 5/9, and that'll give you the temperature in Celsius. So that is it. I think we're back to page one. So that is looking at one of the practice tests. If you take the practice test, you may have different problems just because it has a bank of problems that it chooses from every time you take the practice test. So you may have some of these problems. You may have different problems that are similar. But that is it. If you have questions, email me, let me know whatever you need, and I'll be happy to get back with you to explain further if you need it.